Next up, we have Harry. He is probably the second tallest person in web performance, I believe. Yeah, Harry's an independent performance consultant and one of the absolute best, in my opinion, at it. The number of times where I would find out when I was doing consulting that like, oh, they were also talking to Harry, and then all I can say is like, he's fantastic and you're gonna love him, and it's really bad for competition that way. But I learned something from Harry pretty much every time he talks, at least every time he speaks on a stage, not so much outside of that context, but always look forward to hearing from Harry. So welcome Harry, please.
Thank you very much. In the 1960s, just before they invented ethics, researchers took 5 monkeys and locked them together in a cage. Also in that cage, there was a ladder, and at the top of that ladder was a bunch of bananas. And what happened is, the moment an individual monkey made an attempt to grab a banana, the researchers would spray the other 4 monkeys with water. Not the monkey climbing the ladder, but the other 4 monkeys got punished. This continued for a while until the 4 monkeys, no matter which configuration, the 4 monkeys getting punished for the 1 monkey trying to get the bananas, they decided that they needed to intervene, and they did, sometimes viciously, violently. A very unpleasant experience all around. And after a while, sort of an equilibrium was reached where all the monkeys realized that if I attempt to get a banana, I get attacked. And the other monkeys realized if someone attempts to get a banana, we get sprayed with water. So they decided to leave the bananas, the ladder alone. Kind of boring for a researcher, that. So what they did is to spice things up. They removed a monkey from the experiment and replaced it with a brand new monkey who'd never been part of that cohort. All of a sudden, the new monkey's in there, can't believe its luck. Sweet, some bananas. Starts climbing the ladder. The other 4 monkeys attack. They intervene. They stop the monkey going for the bananas. However, this time, the researchers did not spray any of the other monkeys with water. So the new monkey just doesn't know what's going on. Why can't I get the bananas? Why was I attacked? The next day, the new monkey tries again. I'm going to get those bananas today. Goes to the ladder, gets attacked. And again, the researchers do not spray any of the monkeys with water. So the new monkey realizes, for some reason, the bananas are off limits. I will not go for the bananas anymore. And the researchers take another one of the original monkeys, replace it with another new monkey who's never been part of the cohort, never been part of the experiment, and most importantly, has never been sprayed with water. This continues. The process continues until it completes, until eventually not a single one of the monkeys in the cage has ever been sprayed with water, but has at some point being attacked for trying to grab a banana. The researchers found something fascinating about groupthink, about mob mentality, and about how this knowledge of the correct thing to do or what to do in a certain situation seemed to persist even on a wholesale replacement of a team. I really wish web performance projects worked the same. And I've got enough experience to tell you, they don't. I've tried it. I've tried it a lot. Web performance projects do not work. I cannot hose down a team until they do the right thing. Believe me, I've tried. So what I want to talk to you about today is site speed that sticks. I normally give very technical talks, deep dive kind of talks. Today isn't going to be about that. I want to talk about process. I want to give you step-by-step guidance, instructions, frameworks for designing not a performance culture, because a culture, you need to have a shared kind of vibe. And I think that is sometimes ineffective. You need a performance framework and a performance process. So what I want to try and get you is some practical advice that takes you from local host to live with backstops, safety nets, and everything along the way. So yes, I'm Harry. I'm a consultant performance engineer from the UK, and I'm probably the luckiest guy alive because I get to work with clients like these to find and fix site speed issues. I'm very, very fortunate. I really, really, truly love my job. And I get to do good work with wonderful people. However, not all successful projects stay successful. And it's quite a difficult thing to admit on a stage in front of my peers. But sometimes I'll check back in with a client after 6, 12 months and find that things have regressed, and it's disheartening. And it's never a lack of skill or ability. It's usually a lack of process, a lack of awareness, a lack of confidence. So what I want to do is talk about protocols, different things we can put in place, appropriate tooling, make safer bets on our work, have better predictions, so that we don't regress either as much or hopefully as frequently. The talk's broken down into 5 key topics, and these topics, like I say, are going to take us on a journey from project definition to development to deployment and beyond. There's 5 topics. They're quite brief, they're quite terse, and these will help you build confidence, make better predictions. That's a word I'm going to use a lot, better predictions. How can I work locally? How can I dev on localhost and predict the outcome of that work after it's been through a build step and a deployment and it's in front of customers? Metrics, we'll look at what have we agreed upon. This sounds really simple on the face of it, and it kind of is. That's why I'm going to start with metrics. It's a good piggyback on the kind of stuff Tammy was talking about. But what metrics have we agreed upon, and do we have any stepping stones to help us get there? Are all metrics born equal? Have we got certain metrics that either aren't relevant or aren't useful? Who knows? We'll discuss that. Localhost is really important, and I don't have much great news here. The disparity between localhosts, a powerful development device, and one of those globally more ubiquitous Android phones, perhaps a lower-end device, the void is massive. I've got some slight sort of practical tips and advice here to try and help you reconcile that gap. Backstops and budgets, similar to performance budgeting. These are, at what point do we consider something a regression? Do we fail a release? How do we decide if we fail a release or revert something? How do we roll back? This will hit upon budgeting and monitoring. Then we go into monitoring proper, and a lot of companies, a lot of run tools, or a lot of performance monitoring tools actually tend to get this wrong. I want to discuss some slight misunderstandings that I see in my day-to-day work, in my client work, with the difference between performance testing and performance monitoring, and how to make performance monitoring more sticky, more useful, more relevant. And finally, a playbook. What happens when things do go wrong? One thing I see very frequently in engineering teams, not necessarily performance teams, but just engineering teams that I work with, is this mutual disownership of a problem. We deploy something, the site got slower, and everyone just looks at everyone else like, do you know what to do? Do you know what to do? None of us know what to do, therefore we won't do anything. We need agreed protocols for what we do when something goes wrong. Okay, let's start with metrics. Really simple place to start, but one simple thing to remember is not all metrics are born equal. Certain metrics have different relevance to different parties. That could be the business, developers, users, customers, whatever. So I feel that different metrics exist for different people on different occasions with different levels of disclosure. This last line, disclosure, something I really try and do in my work is something called progressive disclosure. I try and tell people the minimum amount of information possible so that they fully understand the situation. What I mean by that is the CFO of a company should not even know what a time to first byte is. It should not be relevant to them, and it should not bother them. Certain metrics are useful for different people, and what we try and do is distill performance into one metric for everyone. There is value in doing that, but we also need to accept that different members of teams need to focus on different metrics and different bits of guidance. The 3 metrics, do you want to take a picture of that? Did you get one? It's subtly you see, because he's taking a picture with a tablet. KPIs, enablers, and predictors. These are the 3 key classifications that I consider metrics to fall into. This isn't established, this isn't like an agreed sort of thing in the industry, but this is the way I deal with performance metrics on the projects that I work on. So let's start with KPIs, because these are the easiest to explain, the easiest to understand, and these are basically what the project is. What are we fixing? What are we working on? KPIs are understood by non-technical stakeholders, they're understood by the business, and this is basically the metric by which we measure success. A good KPI is very simply a combination of a definition and a target. The definition is simple, that is the metric. We are improving LCP, or Twitter famously had time to first tweet. Whatever the metric is, that's your definition, but it also needs to come with a target. We'll talk about budgets later, but this is an ambition. A target is not a budget. This is something we're working actively toward. What have we agreed on? What is our common goal? As such, KPIs are of interest to the business. When I say the business, I'm including development teams in that. This is a very, very broadly understood metric or suite of metrics. When defining KPIs, it's become a lot easier nowadays because the easiest place to start is probably going to be Core Web Vitals. I don't think Core Web Vitals are perfect, but I think they're about 99% there. I'm a real fan of Core Web Vitals as measurable, impactful, and understandable metrics. So if you're kind of on a, not naive, but like a fledgling performance project, then Core Web Vitals are a really sensible place to start. But there's a really important caveat that comes with Core Web Vitals or any other metric we wish to benchmark ourselves on. Which number on which dashboard of which service? I've come across this before on actual projects. I had a client, this is a real story, I had a client, we want a 1-second improvement in LCP. As a mission statement, that's very simple, and I can help do that. We can achieve that. But where's that second coming from? And I genuinely asked my client this, and they were like, oh, we hadn't thought about that. Me as a consultant, I need to know when to stop working. I need to know when we've succeeded, right? I'm a very big fan of optimizing the work not done. And do you know what? It sounds kind of lazy, but I like knowing when to stop. So, did they mean a second at origin level? Do we try to smooth all the data out across the entire origin and get that number a second smaller? If the answer is yes, that's fine, but I need to know. I don't mind where that number is. I just need to know because that defines my work on the project. Is it a certain percentage of URLs in Search Console? Does the second need to come from a certain cohort of URLs? Are we more focused on product pages than we are on FAQ pages? And I presumably would be, but I need to know. Or are we instrumenting a metric ourselves? Is this metric sort of inside of a non-Google-owned tool? I don't mind if it is. I just need to know. So defining your KPI is a little bit more than just saying, we want to get LCP down to X seconds. It needs to be, we all point at the same screen and we all understand that it's that number there. And it sounds like almost a redundant thing to tell you all. Trust me, this is important. I've seen projects lead to just complete confusion by not agreeing on this simple little nuance. Okay, the second type of metric is kind of a subset. It's a little more close to engineering teams. Enablers. Enablers are not our KPIs, but they directly correlate with them. They're not KPIs in themselves, but an enabler is more or less guaranteed to help us achieve a KPI. Because it isn't a KPI, they don't have targets. We're not benchmarked on these metrics, but we use them internally as engineering teams to ensure we are making steps in the correct direction. So these are metrics that directly influence KPIs, but are not KPIs themselves. For example, all things being equal, if we make a 500 millisecond improvement in time to first byte, we should expect to see a 500 millisecond improvement in LCP, all things being equal. Therefore, time to first byte becomes a sensible enabler. It's probably a good place to start chipping away because all things being equal, for every 500 milliseconds on the back end, we should reclaim that on the front end. This, therefore, makes them of interest to engineering teams. So the KPI of the project might be LCP, but you can't fix LCP. LCP is kind of like it's a bit omnipresent. It doesn't really exist. LCP is a combination of submetrics. So your task might be, okay, well, this sprint, we're going to be working on reducing back-end time to help achieve our goals with LCP. So these are almost guaranteed to help achieve KPIs, but in the interest of progressive disclosure, you probably wouldn't tell your main project sponsor that you're focusing on critical path optimization or that you're focusing on time to first byte. Examples might be time to first byte, which I keep mentioning, or input delay. Right? If you've got a task to benchmark and improve INP, you might determine that input delay is actually a bit of a killer for your particular app. So fixing input delay should, all things being equal, help INP. But your product owner doesn't need to know what an input delay is, right? Progressive disclosure. These metrics are useful to engineering teams, and they define the things you work on. The final metric, and this is a very strange metric, and I think a lot of you will probably not expect to hear me talking about stuff like this, but predictors. These are completely non-user facing, not agreed on or formalized at all. They're not benchmarked, there are no targets. These are just things, quantitative things, that point to potentially good or bad or better or worse performance. So generally speaking, larger JavaScript bundles should probably lead to longer INP. Not necessarily the case, and please take everything in this particular section with a huge pinch of salt. I'm going to come back around to this. Page weight itself is not a metric, it's not a sensible metric, but it stands to reason that a bigger page is probably slower. Predictors are good for reverse engineering and root causing. They're highly quantitative. And the reason predictors as metrics can be useful is that the performance test you run on localhost and the Lighthouse test, or actually no, we don't use Lighthouse. I'll take that back. The synthetic test you run on staging, and then the real user monitoring data you get from live, you're going to get different LTP events at all of them. But at each of those stages, you can measure bundle size. These are highly quantitative metrics that are the same across all different places you're testing that should point you in the right direction. Huge caveat, we're going to come back to these. I would hate it if anyone left this room and said, cool, our new KPI is bundle size. It's not how it works, and we'll come back to it. Therefore, these become of interest to individual engineers when you're working on fixing a particular problem. If first contentful paint increases, sensibly you'd start looking at, well, did we add any render blocking CSS? Number of render blocking files is not a metric, but it's a good predictor of, well, if we added a render blocking resource, that might be why FCP got slower. So these predictors could be something like bundle size, amount of blocking CSS, long tasks. They're highly quantitative, and they can be measured pretty much identically in any environment you care to test. These are great for root causing and great for reverse engineering. So if time to first byte increases, do we make more or longer API calls? The number of API calls itself is not a sensible metric, but it's a predictor. We will come back to this. Lots of caveats. OK, localhost. This is probably the most depressing bit for a developer. Localhost is not a good place to test performance. The difference between localhost and live is pretty much infinity. When I work with performance teams, in fact, no, when I work with teams who don't care about performance, and you have to remember, no one cares about web performance more than someone who's paid to care about web performance. That's true, though. I go into companies and developers just, Harry, how can I automate this? Can I have a tool that does this? Can I lint for this? The problem is, web performance is so contextual, it's hard to statically analyze. It's very hard for your text editor to tell you that's going to give you a bad INP. This is why developers kind of loathe performance testing, because tooling on localhost can't do much to help. I've probably just given someone a really good startup idea there. Localhost is very, very different to live, right? It won't have your cookie banner. It won't have Google Tag Manager. It's probably running HTTP 1. It won't be bundled, so you've got all these optimizations that live has, but then localhost doesn't. You're going to have a very different view of things. But conversely, there's no network cost. It's going to feel very snappy. We're not coming across the network, so things will feel really fast. Testing in localhost is kind of insanity, because it doesn't represent live in the slightest. So what I'm going to do is show you some steps to get a little bit closer. The first step does take a lot of work, and it's also very obvious, but it's critical to know your tooling inside out. One good start here is the new performance panel in Chrome. It's got the live metrics view, and this shows you at the 75th percentile how Chrome users experience the page you're currently working on. Now, because localhost is so different to live, you can't truly emulate why somebody got this 1.01 second. You can't emulate why they got that. But you can tweak your throttling until you get a similar score. You will arrive at that score for very different and very synthetic reasons, but what we're doing is building empathy. If I know that the 75th percentile got a 1-second LCP, I don't want to be seeing a 48-millisecond one, right? I need to build in some empathy. With that said, default throttling might not work for you. This is a really simple, highly effective tip. Experiment with custom throttling. What I did for this, and I did this years ago, is I just went to web page test, looked at what default throttle settings they have, and just copied and pasted them all into DevTools. Now I don't have to use fast or slow 4G. I can use myriad different options until I can tweak and get close to a realistic user experience. I did a whole video course on how to set up DevTools to be hyper-forensics, specifically for performance testing. It's already quite affordable in my opinion, but there's an extra 25% off there. Go and grab a copy of that. This is a weird trick. This is very weird, and I've very rarely used this one, but have used it. If you know, for example, if you use Smashing Mag as an example, you've got a 900 millisecond time to first byte. But on localhost, you're getting 75, 125 millisecond responses. Just slow your dev server down. Sleep your app for 900 milliseconds. Thanks to Daniel Rowe for this. This is the drop-in view plugin. Just slow down your backend, slow down your web server. Just sleep the app for 900 milliseconds. Don't do this while you're also trying to optimize time to first byte. Do this while you're optimizing different parts of the path. But if you know you've got a 900 millisecond time to first byte, give yourself one in localhost. It's really silly, but really effective. Equally, if you know you've got around 800 milliseconds of critical path time, then just go and grab a slow files. Ryan Townsend and I built a tool called Slow Files that on purpose and on demand delivers slow loading CSS or JavaScript, which is funny because all of my clients seem to have built this themselves. Ooh. This is really handy for demoing things, but also Just stick that in your head tags. If you know you've got 800 milliseconds of render blocking time, then force it. You can also just do a really expensive sort of synchronous loop in JavaScript, but it's easier, just stick a slow file in there. Again, don't do this if you're trying to optimize the critical path, but have this if you're trying to optimize image loading strategies. Force slowdown so that you feel what your users might feel. Next tip, and I'm really quite fond of this one, Core Web Vitals are too big for localhost. LTP, like I said, is a big conceptual metric that is comprised, or it comprises many different subparts. Optimizing LTP can't really be done in and of itself. You can optimize subparts, but not LTP itself. So if you're working locally, measure locally. Refreshing localhost and looking for an LTP score in console is not a very sensible way of working because it doesn't take into account, one, how fast localhost is, but two, any other variants. You're not actually improving LTP. You might be improving back-end time. So it'd be more appropriate to look at server response time than Core Web Vitals. And even then, we should go more granular still. This is a fourth type of metric that I didn't list earlier because these are hyper-personal. In that progressive disclosure, you don't really tell anyone about these. Not because they're bad or secret, they're just not relevant to anyone else. Bare metal metrics are a very personal type of enabler metric. For example, you might have a hypothesis. I think inlining our CSS will be faster. So on localhost, what you do is you set up some perf marks and some perf measures. On line, I've got a very strange line numbering, but on line 5, I have got an external CSS file. Either side of line 5, I've got a performance mark and a performance measure that I'm simply logging out to the console. This is a very low fidelity, very simple way of working. I'm trying to remove friction here. I don't want any complex tool chain. What I also don't want to have to do is do 5 performance panel runs that each take 17 seconds to complete or however long it takes. I just want quick feedback. So I've got this, a performance mark, a performance measure, either side of a style sheet. I'm just going to refresh the page 5 times until it's console logged 5 times. For those 5 numbers, I number them in ascending order, 1, 2, 3. I can stop counting at 3 because in ascending order, I know that is my median value. Of 5 tests, external CSS took this long. That's my sort of benchmark. Will inlining the CSS make any improvement? Will it get faster or slower? Now, of course, it's important to measure cold and warm cache. It's important to measure different variables. But if all I'm working on right now is inlining CSS, then all I should measure is the time it takes to parse that CSS, nothing else. No time to first byte, no backend, no nothing. All I'm measuring, not even first contentful paint, just the CSS is what I'm changing, just the CSS is what I'm measuring. Again, hit refresh 5 times. It takes cumulatively, like, less than 10 seconds to run all 5 tests. Again, number them 1, 2, 3. I can stop counting at 3 because I know that's the median. That's how fast inline CSS was. We get about a 600 millisecond saving for inlining CSS. Of course, I would need to test different variants outside of that, such as the cold and warm cache scenario. But these bare metal metrics are really powerful to benchmark yourself as you're working. I wrote about this in a lot of detail quite a few years ago. Measure what you impact, not what you influence. If you know you're only changing one little thing, don't measure everything else as well. These are, like I say, very, very private metrics. You don't need to mention these to your product owner. You don't mention these in stand-up. What you could do, actually, in commit messages, Jira tickets, and stand-up, you could say, I've been working on this. Local testing shows a 600 millisecond improvement. You could probably mention it that way. But these aren't benchmarked. And we don't care if it's 600 or it's 450, or if it's 850 and we found out it was slower. We don't really care. It's all about just benchmarking yourself. OK, the next thing is backstops. Backstops and budgets. So a backstop is a specific type of test that prevents you regressing and then would inform you as to whether or not you might fail or run with a release. Backstops and budgets are very closely related. So performance budgeting may be a concept we've heard a lot about. It's been around for a while. Performance budgets are very useful. A backstop is a specific test in which you've come up against that budget and you need to decide, is it severe enough to regress, or do we proceed with the release? So backstops and budgets is the next section. A budget is very simply, what is the worst possible performance we will accept? So these aren't aspirations. Budgets and targets, very, very different things. A budget is an acceptance of a worst-case scenario, whereas your target is very aspirational. Therefore, It's really easy to set your budgets. Difficult to set targets. You could just pick a number like improve by 1 second, but setting targets should be a lot more considered than that. Setting a budget is actually really easy. You just set it whatever the worst reading was in your last release cycle. If you know that for the last release cycle, LCB has been 3.02 seconds, that is your budget. 3.02 seconds, we will not accept getting any slower than we were this release. You'll notice that about a week before the end of this graph, LCP plummeted. We did some really good optimizations. LCP really improved. What I'm not going to do yet is bring the red line down, because the release cycle isn't over. What this technically means is we could go back up to 3 seconds and still have a successful sprint. But your budgets, you need to be ruthless and you need to simplify. Your budget is simply what was the worst possible moment in the last release cycle. That's your budget. And in fact, unfortunately, you can see that back-end time has started creeping up, and therefore so has LCP. We've still got a few seconds of headroom before we break our budget, but this is a point where we would start to investigate. However, we'll start to investigate because we've seen it. No alert has been fired because no budget has been broken. There's no backstop yet. This is where synthetic testing comes into it, and I've got very strong thoughts on synthetic testing and synthetic monitoring and real user monitoring, et cetera, et cetera. I'm going to come back to that in the monitoring section, but for now I'm just going to say this. Synthetic testing is for testing. This is where you find your backstops. This is when you decide whether or not to roll a release. Real user monitoring is for seeing how things work in the wild, and there's a really important distinction. Synthetic is not for monitoring, it's for testing. Real user monitoring is for monitoring. So at this point, we're going to roll a release, maybe stick it on staging, and run some tests. I don't have any hard and fast numbers or facts or even real advice. This is a very personal sort of team decision about whether you fail a release or not. But basically, what you can do is the predictor metrics that I spoke about earlier, you can start to use those as sensible predictions as to whether or not a release could regress a metric. I refer to these as tripwires. The predictor as a tripwire is quite a useful tool. A tripwire is basically, we've stumbled into something, and that is going to set something off. And what it's going to set off is not going to be particularly nice. You can use predictors as tripwires. Now, I mentioned predictors aren't metrics in and of themselves. A KPI like have only one blocking style sheet is not a sensible KPI. I mentioned that predictors are good for reverse engineering. After you've got a bank of real user data, you can start to make slightly more informed decisions on very quantitative metrics. For example, this site's been live for a while. We could plot bundle size against INP. Now, what this graph shows me is that when bundle size goes over 60 kilobytes, INP goes over 200 milliseconds. This is very rough, loose math. Again, huge pinch of handful of salt. Because you could halve your bundle size and double your INP just by writing bad code, right? This isn't a direct input-output. But what we're trying to do here is just build that confidence using real statistical empirical data. I can see from this graph that when bundle sizes tip 60 kilobytes, INP goes over 200 milliseconds. It could well be that it's a one function in that 60 kilobytes, and 59.9 of it is actually just completely safe. This is not a hard and fast input-output kind of methodology. But you could start to plot these. If you've got the real user data, you can start to work back. Is there any correlation between CSS size and FCP? Cache hits and not. Using real data, you can start to get quantitative metrics that are the same in localhost, staging, and live. A quick note then on budgets versus targets. I've mentioned this briefly, but budgets are your backstops. What is the worst possible scenario we will accept? Targets, on the other hand, are ambitions. Targets are things we will strive for and actively work towards. Your target basically is your KPI. I first wrote about this, I think 4 years ago, perhaps. Performance budgets, pragmatically, just takes a lot of the thinking out of the problem. Don't overthink it. Just whatever the worst thing you had in the last release cycle, that's your budget. Monitoring. Okay, I'm going to come back to this whole synthetic versus RUM thing. The M in RUM stands for monitoring. There is no M in synthetic. Don't use synthetic tests for monitoring your site. I've got a good kind of amusing cautionary tale here. There's a quote often misattributed to Albert Einstein from a woman called Rita Mae Brown. She wrote a book in which one of her characters said insanity is doing the same thing over and over again and expecting different results. If you've got a site, like mine, for example, in fact, I'm going to go straight into the story because it's my fault, the example is me. My site very rarely changes. It only changes when I publish a blog post. It doesn't really change much at all. Yet, at 3 p.m. every day, SpeedCurve wakes up, goes to my site, has a little look around, and tells me what happened. My site doesn't change daily. Yeah, I'm testing it daily. What's the point? What is the point? Only do synthetic testing when you're debugging something or in response to an action, which is usually going to be a deploy. Running this same test with the same conditions, same environment, over the same URLs day in, day out, you're not actually measuring performance, you're measuring variation in tests. Were the test results different? Not was the site different. There's a subtle but significant difference there. The example is me. Sometime in mid-July, total blocking time on my site just plummeted. Fuck yeah. But why? I didn't do anything. So I was like, oh, what did I do? And again, the only time I would ever get, I don't have a CMS either. If I write a blog post, it's in a text editor with a commit. Any change on my site has a commit associated to it. So what did I deploy? Nothing. Then your next logical thing is, well, okay, there's no CMS. There would be a paper trail if there's a code change. It has to be a third party. So using a RUM tool, I found out that Twitter's total blocking time had just plummeted. Like their long tasks had just completely decreased. I was like, oh, amazing. That's really great work. Now, unfortunately, SpeedCurve doesn't capture, or many RUM tools don't capture the contents of a file. So I couldn't really see any changes. I couldn't get a diff of what Twitter had actually done with their widget.js. That meant I couldn't even take a checksum to check that they had changed. And also, because you're pointing to a nice clean URL, widget.js, there's no hash. So I couldn't actually tell if this file had changed. So I dug a bit deeper, and I thought, well, you know what? Content length is a good proxy for if the file has changed or not. Did they reduce the size of the file? You know, whatever. Content length 27597. That was on day 1. On day 2, content length was 27597. What? The file hasn't changed. Yet total blocking time completely plummeted. Something changed, and if we go back, something changed and it stayed changed. It was persistent. This isn't a blip. If you run a synthetic test over the same conditions, same URL, day in, day out, you're not measuring a difference in the site. You're measuring a difference in tests. The files were the same. The exact same. Do you know what changed? SpeedCurve upgraded their test agents from Chrome 115 to 126. This is also a good cautionary tale. If you just wait for your users to catch up, well, that's how it got faster. This wasn't a change in anything I'd done. It wasn't a change in any code that had been written. It just SpeedCurve updated their test agents. This is why, this is a really good cautionary tale. Be very careful trying to use synthetic testing as a monitoring device. If your page changes lots and lots outside of deployments, like you've got CMS content, user-generated content, if your page does change a lot outside of a deploy, then still use RUM. Don't use synthetic for monitoring. I just don't see the value in it. It's good for reverse engineering. So what I would really like to see, and I adore SpeedCurve, I really, really do, but what I'd like to see, if there's one takeaway from this talk, can we just change these words out? So don't run scheduled tests 5 times a day. It should be, I release 5 times a day. That's what I probably need in my budget. I'm going to need 5 deployment tests per day for 15 URLs on the one site I have. It's a lot cheaper to use synthetic as a monitoring tool, but it's not as effective because all it's really doing is showing you variation in tests. The next thing with monitoring, and again, it's all about reduce, reduce, reduce. My aim with clients is to simplify. The progressive disclosure. I want my clients to care about as little as possible. Only alert on your KPIs. Don't trigger an alert if an enabler has regressed, because we're not measuring ourselves on enablers. Reduce the amount of alerts, reduce the amount of noise. Only alert if something significant and business-facing has happened. I've got another good story for you. Well, it's a story. You'll decide if it's good. I've been working with this client since the beginning of the year. First thing I'll tell you is that I don't have any remit over like platform, back-end, anything. I'm just doing very, very, very front-end optimizations. Unfortunately, this site has been regressing in time to first byte dramatically and consistently all year. This means that I'm having to work twice as hard just to keep above, just to tread water. Every optimization I make on the front end, their re-platform project has taken that back away from me. I have to work twice as hard to just break even. This project is getting quite stressful. I've escalated this, and I've told them, look, this is P1 for you, but it's really affecting the rest of this project. All the performance work we're doing is ultimately for nothing unless someone works out what happened here. And we know what happened. It was a re-platform into a very popular cloud platform, which isn't any faster. This went from on-prem to a cloud provider, exactly when it went from green to orange. Not a great success. But anyway, I keep telling this client, you need to be terrified about time to first byte. Time to first byte, it's not a KPI, because it doesn't affect the user, but it's a huge enabler for us. I keep stressing to my client, time to first byte, be scared of this, be scared. If you look at the correlation between LCP, which is the blue line, and time to first byte, that's basically linear. In fact, it's so linear that I decided to pull out the data into a Google Sheet and check the correlation coefficient. On a scale that goes from -1, which is -1 is like perfect negative correlation, to 1, which is perfect positive correlation, this scores a 0.995. Every 100 milliseconds we lose on the back end, we lose 100 milliseconds on the front end. It's that clear. And I've been drumming this into them since mid-spring. You need to be terrified of your time to first byte. Anyway, I was off the project for a couple of weeks. And when I got back and I sort of caught up with the team, hey, how are things? Anything changed? Anything I should be aware of? They're like, yeah, we had a pretty serious regression. Look at time to first byte. So they made a change. Time to first byte skyrocketed. Now, because I've been telling this team for months, you need to be scared, time to first byte. They left it live for a couple of days. They were like, oh, Harry's not around, what do we do? Pull it, just pull it, pull it. Look what happened to LCP in the same time. This is a very succinct advert for what a piece of shit client-side rendering is. The reason LTP was as high as it was, the blue line, is because we were client-side rendering the homepage. And I said to them, look, a big win, just a bit of a PR thing for the team, is let's just fix the homepage. Everyone loves the homepage. That's why everyone sort of gets their fingers dirty on the homepage, right? Let's fix that. Let's switch to server-side rendering. Now, switching to server-side rendering did increase time to first byte, actually by much more than we would have predicted. But look what it did to LTP. That's the fastest the homepage has ever been. But they reverted it because I told them, be scared of time to first byte. So we instilled the rule, or installed and then instilled this rule, only fire alerts on KPIs, only revert a release if a KPI has suffered. That was bad communication on my part. It's my fault that this happened because I didn't have that framework in place. I don't have the data currently, but this is actually a wonderful success story because I said, look, let's put this back live. We are going to get an increase in time to first byte. What I'd also like to do is just set up some APM. Let's instrument the back end and see why we got such a big increase. A guy on the team, or two guys on the team, very can-do. I love working with them. They were like, OK, we'll take a look. We'll see what it is. They worked out what the time to first byte issue was, and they squashed that as well. So not only did we revert this change, go back to this model where time to first byte was high, but LTP was low, we got now to a point where they're both really low. We can now, in a few days or weeks' time after this release, reset our budgets. The problem is, when you reset your budget to a much lower number, everything just gets way more difficult. It's like this compounding, like, oh my god, minus 1 second now. Always follow the numbers. Be ruthless and stick to your guns. Don't fire an alert unless it's an agreed-on KPI. I don't care what your time to first byte is. If time to first byte is so bad that it pushes LCP over budget, that's when I'm worried, because it's pushed a KPI over the line. If it's not a KPI, don't fire an alert. OK, last section, playbook. It's all for nothing if you don't have a plan. If you push a regression live, or you push something live which becomes a regression, there's no good being like, should we just pretend we haven't seen that? So you need to know what to do. Simplifying it and codifying it makes it a much easier response, right? We had Michelle Vu a couple of years ago on stage here, and she said, fighting regressions took priority over optimizations. And this really speaks to me. I love this. Because there's no point trying to make optimistic upgrades while you're losing time elsewhere. I call this containment. When I first start working with new teams, there's a lot of excitement. Oh, well, we could put speculation rules live, or what about back-forward cache? And my first thing is, no. Let's just contain what we've got. If you're going to do it, only do it once. Let's tighten up our caching strategy. Let's contain what we've got, and then we'll start making opportunistic upgrades. There's a saying in English, which is, there's no point rearranging the deck chairs on the Titanic. There's no point tidying up the seating if the ship is sinking. Quite appropriately, There's a much nicer saying in Dutch, dweilen met die kraan open, which I think I hopefully got right. Mopping while the tap is still open, right? There's no point mopping the floor before you've turned off the tap. I've got a client here in the Netherlands, they actually taught me this phrase on a project, and I love this phrase. There's no point mopping if the tap is still on. So containment is really important. So in the interest of containment, we need a response, a proactive, replicable, do it with your eyes closed response to regressions. It's all for nothing if you don't have a plan. The plan can be as simple as your response is a function of the severity of the regression and the duration of the regression. Every number I'm about to show you next is an example. Don't write these down. Don't go home with these. These are examples. You need to plug these into your own discussions with your own team. But for example, you could look at severity as a threshold like acceptable. A 3% regression, that's fine. Hopefully you've got your own data which proves where that cutoff point is. You can see the decay in conversions perhaps. But you might define, I don't know, less than 10% as acceptable, 10 to 25 as moderate, 25 to 50 as severe, and anything over a 50% regression is critical. But those on their own are kind of useless, because we need to factor that in with duration. You might have a momentary blip. Something might go really badly wrong, but it resolves itself within a couple of hours, and that might have been a critical regression. So what you need to do is contrast this with how long has it been live. So duration, again, plug in your own numbers. Do not take these as rote. Temporary, I would normally be like 24 to 48 hours. This could just be a blip. This could be cache misses because of a deploy. This could be a malformed Google Tag Manager. This could be caused by a bit of experimentation, an A/B test. This could right itself. So don't panic just yet. Sustained, anything over 48 hours. Long-term is longer than one release cycle. It's been live for a while now. And unresolved is like, do we even care anymore? Like, it should never get to this point. And the project I'm working on with the time to first byte, I've escalated it. And it's like, well, we're not really sure what's going on. I'm now considering that unresolved. Many release cycles. So, for example, a KPI regression of over 10% for 1 week requires remediation in the next sprint. This is your framework. And again, everything in yellow needs to be filled in by you and your team after you've agreed on it. But as an example, it could be this. Or a KPI regression of over 100% for 1 hour requires immediate rollback. Or a KPI regression of over 25% for 1 day requires remediation in the current sprint. So we're not going to wait and factor the fix into the next release cycle. We're going to do it now. We're going to do it today. You notice that every single example has been a KPI regression because you shouldn't be alerting on anything that isn't a KPI. But as conscientious developers, you may have your eye on dashboards. You may be keeping an eye on things. So you might notice that, like my client did, time to first byte got bad. An enabler regression never requires a rollback because it's not a KPI. An enabler regression of over any percentage for any amount of time needs the team's attention over the next sprint, for example. Or a predictor regression of over any percent, so, bundle size went up by 15%, needs my personal attention over the next sprint. I'll keep an eye on it. We don't take any action yet because if it hasn't tripped a KPI, we technically don't care. By codifying these, it means that when it does hit the fan, when something does go wrong, everyone knows what to do. It's agreed upon. You don't need to ask your manager for permission to roll back a release. You've got it written down somewhere. It's agreed that you know what to do when. OK, you need a framework to fill in these blanks. I need to hurry up because I've got a few minutes left to get through this very last section. Early triage. When the alarm does sound and that notification does go into Slack or you do get an email, what do you actually do? Early triage is a way of kind of trying to democratize triage. We're looking to answer who, what, when, where, and why. This framework means that even non-technical or non-performance experts can start helping to triage. Nothing worse than having one performance member on a team who has to deal with everything. This framework helps to democratize the triage process. This sentence has a nice rhythm to it, but the actual order you do them in is very different. So we're going to start with what. What has regressed? This is dead easy because the email told you. LTP regressed, INP regressed, time to first tweet regressed. This is the easiest one to work out because you've been told. The alert has told you. So we'll move on. When. This is critical. When is basically, when did it start, and is it still like that? The quicker you can jump on a regression, the easier it is to root cause, the easier it is to work out what happened, and also, the longer you leave a regression, the more that is going to be built on top of it, and more persistent it will become. Does it align with anything? Does it align with a deploy, a marketing campaign? Does it line up with an A/B test? Are there any external factors that kind of line up with this regression? Where? Was it a business-critical part of the site? You might just be monitoring your site as a whole. Ideally, you'd be monitoring specific pages and page types, template types. But if you've just got a score that's bubbled up from somewhere, is it a business-critical part of the site? I'm willing to guarantee that as an e-commerce firm, you would be more interested in regressions on your product details page than your FAQs page. So is it business-critical? Who, right? And this is the kind of tricky one. Who do you think owns the problem? Can you pinpoint a team? Is it very obviously a design system team issue? Is it very obviously a platform issue? If the regression happened on the back end, it's very unlikely to be a tag manager problem. So can we, not to point fingers, but to go and start getting assistance? Hey, look, I don't really know much about performance, but I think the tag manager change did this. Can you help? Not to blame anyone. Well, it could be, but that's not the design of it. It's just to find out who can assist. Finally, why? Can you actually conduct any early triage? This is where knowing your enablers and knowing your predictors becomes very, very useful. Can you conduct early triage? Why did LTP regress? Why is INP regressed? A different project I was working on, LTP spiked. The first place I will look instinctively if LTP spikes is time to first byte. That's an enabler. That's a LTP is a KPI. Time to first byte is an enabler that I know will help me get there. No change. Time to first byte didn't change. So my next logical step, this requires intuition, it requires domain knowledge, as in this is easier for performance engineers than it is for not. Next logical place I would look is first contentful paint. Right, the slowdown happened somewhere between the HTML arriving and starting to render it. Normally, that's going to be in your head tags. Andy Davies sat in the front. He once told me very succinctly, the head tag is the biggest single render blocking part of a page. And when it's put that simply, it's like, oh yeah, it is. The problem has probably happened somewhere in the head tags. So let's look at some predictors. I started slinging stuff at the wall. What's really weird here is I started plotting blocking JS and blocking CSS requests. On average, across the time period, we had 1 blocking JS and 0 blocking CSS. So what's kind of weird now is, on the day in question, blocking JS went from 1 either side to 0. So it's not blocking resources in the head. Well, now I'm really getting confused, and I'm sticking everything at the wall. And I started to plot every milestone timing that I can think of. OK, so DOM content loaded went up, so did DOM interactive, and so did Next.js before hydration. Something's happening synchronously, and it's happening in the HTML. DOM interactive effectively fires when the browser gets to your closing HTML tag. So what that means is the problem happened somewhere between the opening HTML tag and the closing one. It didn't happen in the head tags. If it happened just in the head tags, the page could have been parsed, even if not rendered. The knock-on effect is coming somewhere out of something synchronous in the regressions coming from inside the page. That wasn't meant to be part of the talk, and based on Tammy's one laugh, I won't put that in the talk again. But one thing that I noticed is that this correlates highly with something that's happening. It must be happening inside the page itself. It's not external factors. It's not on the back end. So I decided to plot HTML size. The only one metric I could find that correlated with this big uptick in LTP, FCP, etc., was on this day, there was a slight uptick in HTML size. I caught this after it happened. It hadn't tipped anything, it hadn't triggered an alert. This was just like an intellectual exercise for me, just to well, let's see what went down. And I had to start pushing the figures to the 95th percentile until this became apparent. But yeah, that's how you sort of conduct this early triage. Start at the most obvious candidate and get to sort of weird stuff like this progressively. OK, key takeaways from my talk. Do everything you can to increase your confidence. Make everything a hedged bet. Make everything slightly more informed than not. Use the right tool for the job. Localhost isn't the best place for performance testing, I am afraid, so do what you can to help yourself there. Don't use synthetic for monitoring, use it for testing. Have a plan of attack. Make sure that there isn't this shared disownership if and when things do go wrong. Agree to everything and commit to it. Be ruthless and stick to your guns. If you said you will regress on a 10%, roll back on a 10% regression, a 10.01% regression counts. You have to stick to your guns, otherwise it's all for nothing. With that, I've got 2 last things to say. Firstly, thank you very much for listening. You've been wonderful. That was quite a dense talk. Secondly, if you want to talk about this, you want advice on this, I'm around for the rest of the event. Catch me in the hallways, whatever. Or if you just want me to come and set it up for you, we can talk about that as well. But yeah, thank you very much for your time.
Yeah, pick one. That's good. Thanks, buddy. That was really good. I'm gonna be honest with you. When you first said what the title was gonna be, like I had read it and I thought it said site performance that stinks, and I feel like this was actually a much better talk.
Well, before
yeah.
I put the whole monkeys thing in there, my joke was going to be it said site speed with a space. Site speed that sucks. I was like, no, that's actually just a bit. That's pretty lame.
Yeah. No, this was a better talk. I enjoyed this more. So it's good. Also, you have to give the bananas back. Like, are those? Are you going to sharing those?
I've got some angry researchers waiting outside.
Moving on. No, we had so a few questions came in. I don't think we'll have time for all of them. So like, I do encourage anybody to like definitely pull Harry aside. He likes chatting about this kind of stuff. The one thing I wanted to poke on definitely was the synthetic part of it. Synthetic, that's because that is a fairly significant shift, right, from monitoring to the testing perspective. So just to clarify, it's not that synthetic. I mean, I think you made it fairly clear. Like synthetic has value. At what point do you feel like? At what points should you have the testing set up, and how do you know you have comprehensive enough synthetic testing to be like, okay, we can ditch the monitoring aspect of this?
So well, I would never ditch the monitoring aspect.
Of the synthetic part, I'm sorry.
Oh, okay, yeah.
Okay.
Yeah. So normally I'd start at the end and work backwards. Normally, ideally with a client, you'd have enough time with them to set up actual monitoring, run, and work back. So what you try and do is choose the pages and the flows or the journeys that are important to you. Start with run, gather as much data as you can, and work back from there, like what are the important pages, flows, etc. Your synthetic tests should still be reliable, so what I'd encourage people is don't use default settings in whatever performance tool you're using. Try and make sure your synthetic results do at least mimic a live-like number. But mainly for me, I would only ever use synthetic as a backstop in response to a deploy, in response to like a programmatic or atomic change. I really just don't see much value in running the same test over and over. And if your site does have a lot of user content, it does change frequently, it's not a good reason to use synthetic. You should be using RUM. So synthetic is good for in response to a deploy or an atomic change that you can actually pinpoint with your predictors, with certain levels of confidence that based in real world data, we know that if time to first byte goes over X, LTP will go over Y. Always in response to a deploy. That could even be in live. It doesn't even need to be on a staging environment. But the primary driver, the primary use case for synthetic is reverse engineering. Live has shown a problem. LTP has regressed. I'm going to run some tests now and see if I can work out the root cause.
Sure.
It's a broad generalization, but I think synthetic as a monitoring tool isn't particularly useful.
So then one of the other questions that kind of followed from that is, this is, I think you're onto something with like the variation, right? Because I've seen in my experience, like the variation in synthetic tests when it does occur can be a big problem for organizations because it's hard to explain. You start to lose trust, like it becomes an issue. And so I think, adjusting expectations and how we use that makes a lot of sense. Mm-hmm. What about variation that happens in RUM data that may come from outside perspective? So the example given in this, like, increased bot traffic suddenly like causes a change that obviously is out of your control. It's I guess a variation. How do you account for that and deal with that?
So I do come against this a lot. So I've got a bit of a cold and now I've sort of stopped talking. I've got a sore throat. I do come up against this a lot, external factors, and just generally education on how to interrogate data, which historically I've not been a natural at, but segmenting things. So, okay, we've got some weird behavior. Really good example. I've got a client where their LTP has rocketed. And when you look at the data, that correlates really well with redirects. So it's like, okay, you've got loads of redirects on the site. And they can tell me, of course they know, we don't actually have that many. When you plot the data a different way, in histograms, it's like, okay, for every 40,000 LTP events, you've got maybe 1,200 redirect events. So knowing how to segment data properly so that you don't draw incorrect conclusions, I don't have any advice on that. It's just something I've had to learn and read about myself. Sure. But given the data I'm looking at, what a potential influence is, do I start by segmenting on mobile, desktop? Do I start segmenting country? Do I start segmenting X, Y, and Z? Third parties. So the external influencers, they do obviously rear their heads in RUM. I would just start interrogating the data I've got before I start running any tests.
Okay. And one last one, you had mentioned like that you thought core web vitals, 99% there, solid starting point from the KPI perspective, right?
Yes.
Do you have a recommendation for a company who's just kind of like starting to go down that path? You had alluded a little bit to, choosing whether it's going to be improvements on the origin, improvements for a cohort of pages. Like, do you have one of those that you recommend? Like for somebody who's like, hey, we don't know where we want to make our 1 second faster. Do you prioritize? Like, what is your recommendation?
Prioritize one of the 3 metrics, or?
No, more like, do you decide as a company, like, look, I think we should be targeting a subset of your pages for our initial round of work, and then how do you prioritize that?
It depends what their business motives are. So it's like, if it's SEO, then, again, none of us actually know what the impact of core web vitals on SEO is, but I'll be like, okay, just focus on, what's the word, like, mass appeal, like broad strokes, get everything faster if it's for SEO. If it's an e-com firm, well, let's focus on metrics that historically correlate with conversion. So LTP seems to be a very strong predictor for purchase. I think Speed Curve did research that said INP is quite a strong predictor for purchase on mobile, perhaps. Tammy's nodding, have I remembered that correctly? So using anecdotal data from external sources, WPO stats, if you've heard of that. Find out, like, hey, we've got limited resources, limited domain knowledge. Someone in our similar industry achieved this with this metric. We'll start there. And so we can either set aside time, knowledge, budget, resources to instrument and find out our own sweet spot. So it depends. If it's like a financially driven case, like you're a charity, you want to get more signups, focus on your checkout flow or your sort of donation flow. If you're, I don't know.
That helps. No, that helps. Okay. That works. Yeah. Good. Well, thanks, Harry.
Thank you.
I always appreciate how systematically you approach this. I always get a lot out of that. So thank you.
Man. Thank you so much. Thanks, everyone. Cheers.